So if your injector duty cycle is going beyond 80, beyond 90, even beyond 100%, you probably want to consider a new set of injectors, a bigger set of injectors. You also may want to consider a new fuel pump if you haven't got one already, because the other symptom of having an air-fuel mix that's just leaner than you'd like it to be, maybe your air-fuel mix is in the 12s instead of the 11s, but you've already added as much fuel as you can in the fuel map and the injector duty cycle just seems maxed out at 100%. Well, it could be the injectors, but it also could be the fuel pump, because you got to remember the fuel pump has to supply additional amount of fuel dependent on how much boost you're running. So there's two possibilities there. If you're leaning out, especially up top when the airflow is the greatest, and you've tried to add fuel and the injector duty cycle has gone up, but you're just not getting anything in your wideband log, it's probably your fuel pump. I've just logged some other things: speed, coolant temp, air temp. Those can be useful if you happen to be worrying about them for any given time, but in this case it doesn't do us any good, so we'll just ignore those for now. So that gives you a basic idea of the things to look for and just how to read a data log in general. Knock sum is a great first indicator, wideband, timing advance, and load. And if those values match up roughly to what you're expecting, then you hopefully don't have to do too much work on the tune, but it's also possible that they're all over the place. From the factory, you'll note that wideband is probably significantly richer than what we have here, and it's done that way intentionally for Mitsubishi for safety, because a richer fuel mix will be more resistant to knock. It will be more resistant to someone accidentally pumping lower octane fuel into the car, 87 or 91 instead of 93. And it'll waste gas, and it'll also reduce power output. So getting it up from the stock 10 range up into this mid 11 range is a great way to start adding power to your tune by taking away some of the fuel that Mitsubishi put in there from the factory. And the other thing would be making a timing map that kind of is appropriate, especially when you start changing the amount of boost that you run in the car, because let's bounce out to EcuFlash and bridge over to the next topic. We'll open up a fuel map and a timing map, and we'll look and see what happens as we start modding the car. Because most people, let's face it, you don't drive a stock Evo, you do at least something to it. So in most cases, people will increase boost on the car. It's a great way to make more power, more boost, more power. But what happens when you start changing the boost profile is you start hitting different values in these 3D maps. So from the factory, you may be progressing from this portion of the timing map down and across in this manner, where you're never really exceeding this boundary and going into this negative timing range. At 2000 RPM, you may not be experiencing anything more than 120 or 140 load. But if you turn the boost up, and you recall load represents the air that the engine's consuming, this could shift you over 3, 6, shift you over a considerable number of cells depending on how much boost you're running. So just by turning the boost up, you've drastically affected your tune. You could have potentially shifted yourself from maybe 8 degrees of timing to a complete opposite end of the spectrum. Maybe you're now running negative 9 degrees of timing. And timing, along with air fuel, are what are going to determine how much power your car makes. In general, more timing will make more power. So as you begin to turn up the boost, the same thing happens on the fuel map. If in the stock fuel map's case, and the stock configuration of the Evo running 20 pounds, you may only be hitting the 240 load column, and we're using AFR values in the mid-9s here. But as soon as you turn up the boost and you start progressing into these other columns, we're now hitting significantly richer lower AFR values, and it's affecting the fuel mix significantly. So as you turn up the boost, you don't necessarily gain power out of the car. That's why a tune is a very important component in modding your Evo. If you want to gain power from the mods that you do, you definitely should have an appropriate tune that is aware of those mods, and you're definitely going to want to take full advantage of data logging to be able to understand what needs to change in these maps in order to get the most out of your tune. So if you're still following along and everything makes sense so far, what we can do at this point is we go back to our EvoScan log file, is we can start to match up. Now I can tell you straight off the bat that I'm definitely running, as we run 25, 26 pounds of boost, that's definitely more than stock. As you're probably familiar, stock Evo running about 20 pounds. So we've turned up the boost here, and we're still running positive timing. So that means this map has been tuned already. We're not on a stock map at this point. So these EcuFlash maps won't necessarily match up with what this tune was in at this state at this time, but it's good. It's still good to show you for example's sake. So in this case, the engine's logging about 280 load at about 3160 RPM, which is approximately 24 pounds of boost and 4 degrees of timing. So let's assume, for example, that we want to try adding timing to these cells in order to get some more peak torque out of this car. What we would do is